Okay guys, we're on to our third and last type of model. This is the simplest model. It's probably the model that you thought described most drugs in their therapeutic ranges. It's called the linear model. So if we take our Emax model, so not our sigmoid Emax model, but our Emax model, and that is here, right? If we take our Emax model and look at when the concentrations that we're achieving are much, much less than the C50. So let's say our C50 is 100 milligrams per liter. And let's say the concentrations we're achieving are up to 10 milligrams per liter. Let's say they're 0 to 10 milligrams per liter. So we can say that our concentration is much less than the C50. So then this could fall out of the denominator. Remember our rule about a sum in the denominator. And so that can fall out in importance. It doesn't mean that it's equal, but it's approximately equal then to Emax over C50 times concentration. So this concentration stays in the numerator. So then we have concentration versus effect, and we have a straight line, don't we? With the slope of that line, this is going to be E. Let me just erase some of this. Let me erase it all. Okay, so if we have E is equal to Emax over C50, it's not equal, but approximately equal, times concentration. This is the same thing as Y equals mx plus B, and this will be 0. So if we look at our graph, it's going to be the concentration and effect, and our y-intercept is going to be at 0 here, right? And we're going to have a line that goes like this. So as we increase our concentration, our effect will increase in a linear fashion. And then m would be our slope. So the slope of this line is going to be Emax over C50. Pretty cool, huh? I think so. I hope you do too. So that's what our line will look like, again with our concentration being on our x-axis and our effect being here on our y-axis. This is going to be when concentration is 0, the effect is 0. And we're going to have a linear equation. E equals Emax over C50 times concentration. So Y equals mx, and then the B is 0, right? So in this case, if our Emax is 100, well, we can't really see it, can we? Because we're up here. The gamma is 1, and the C50 is at 10. So, oh, I'm sorry, 10. So that's way out there, right? 10. If the concentration is at 10, it's way over there somewhere because this is just 1.2. So we can't really see it. But that's because the concentrations are low, right? The concentration has to be much less than the C50, and the C50 here is 10. So these concentrations you can see are much less than 10. So that's the linear model. So we have three models then. We have the sigmoid Emax. This is the most complex, and it's where E is equal to Emax times concentration raised to the gamma there, which is our slope effect, and C times over C50 raised to the gamma plus concentration gamma. That's our sigmoid Emax model. Our Emax model, which is a little simpler, is going to be getting rid of this here. The gamma is always equal to 1, so the effect will be equal to Emax times concentration all over C50 plus concentration, and we don't have to have these gammas here because they're all equal to 1. Okay, and this one Then finally we have the linear model. And here, that's when the C50 is much greater than the concentrations that we achieve. So this falls out. So we have E is equal to E max over C50 times concentration. Okay, so hopefully you understand all of those. That's it for our models. Now we're going to talk about combining modeling pharmacokinetics with pharmacodynamics in our next one.